Okay, today we're going to move on to section 8.2, and we are going to continue to look at graphing parabolas. All right, last week we looked at graphing parabolas using XY tables and putting in a certain group of values and seeing what came out, plotting those on a picture, and then connecting all of the dots. Well, we're going to continue to do the same thing today, but we're going to add one extra term to every one of our problems. So we'll start off with f of x, or we'll start off with y equals one or the other. And then what we're going to have is some number with an x squared, and then we're either going to have a plus or a minus, and then another number. So some examples of the types of graphs we're going to be looking at would be things like y is equal to 2x squared plus 4. Or maybe y is equal to negative 3x squared minus 1. Or we might have f of x is equal to 1/2 x squared, plus 2. Things like that. These are going to be the types of examples we have. And what's new today, is that we're adding or subtracting a number on the end of every one of our equations. And we need to talk about what that plus or minus number does. So let's start with an example. All right, and I'll begin with the initial equation. So our initial parabola equation here is going to be an easy one, just x squared minus 4. And we're going to create a table. Now, just like we did last week, we're going to use the same batch of values. And the values, once again, are going to be 0, 1, and negative 1, 2, and negative 2. Same batch that we had last week. And we're going to put those numbers in one at a time for x and see what comes popping out for y. So we'll put in negative 2 for x and see what comes popping out for y. We're going to put in negative 1 for x and see what comes popping out for y. We're going to put in 0 for x and see what comes popping out, and so on. We'll put in 1, and finally we'll put in 2 and see what comes popping out. Now, if you remember your PEMDAS, we always do exponents, E, before we do S, subtraction. So we have to do the exponent first, then we have to do subtraction second. So for the very first one, negative 2 squared is negative 2 times negative 2, so that would be 4, and 4 minus 4 gets us 0 as a result. Negative 1 times negative 1 is 1, and 1 minus 4 is negative 3 as a result. 0 times 0 is 0, minus 4 is negative 4. 1 times 1 is 1, minus 4 is negative 3. 2 times 2 is 4, and 4 minus 4 is 0. All right, and so when we take those ordered pairs, our x's and y's, and we graph those, and I'm just going to be taking a photo here of a piece of graph paper and shrink it down a little bit. There we go. Then the points we end up with are left 2, 0, left 1, down 3, stay in the middle, go down 4, right 1, down 3, and then right 2, and then don't go up or down. Now, I won't do this every time, but I'm just going to identify those. So that's left 2, don't go up or down. This one is left 1, down 3. This one is stay in the middle, go down 4. This one's right 1, down 3. And this point is right 2, don't go up or down. All right, so those are our 5 points. Now we're going to connect those with a smooth curve. And so again, the way basketball or a baseball or a softball might fly through the air, we're going to connect those with a smooth curve. Right, and then just using our imagination, we know that this curve continues up in this direction, and this curve continues up in that direction. And there's a really good picture of the parabola for y equals x squared minus 4. Okay, so there's our first example. And what I need you to notice is that instead of a parabola starting at the origin, like all of ours did last week, this parabola starts down 1, 2, 3, 4. It starts down 4 from the origin. And what I'd like you to notice is that the subtracting number is the same. It's minus 4. So what ends up being the case, what ends up being true, is if we go back to that original that I wrote on the first page, when we have either f of x or y equals ax squared plus or minus b, what's going to be true is that the plus or minus number that's on the end of all of our equations is going to move the vertex, and remember that's just the starting point for our, excuse me, that's going to be the starting point for our parabola. It's going to move the vertex up or down in the same direction as B. Up or down in the same direction as B. Okay? And so that's going to be helpful to us. It's going to be helpful to us because we can fairly quickly then locate, oops, sorry, I chose the wrong tool there. There we go. We can very quickly locate the vertex or starting point of the parabola. Okay? Also, if I go back to our first example, and I choose a different color like blue, we can also see where the line of symmetry is going to be, just like we talked about last week. The line of symmetry is always going to go through the vertex. So the parabola on one side looks exactly the same as it does on the other side. It's always going to be a mirror image on either side of the line of symmetry. Okay? Alrighty. So let's just try a couple more. That's the main idea, is that whatever plus or minus number is on the end, that moves the starting point up or down in the same direction as B. Okay? So let's try another one. Here's another example of a parabola. So let's have this one be negative 2x squared plus 5. Okay, and what we just talked about, any plus or minus number, it's going to move the starting point, the vertex, up or down in that same direction. So when we get around to our picture, we're going to see that our starting point has been moved up 5. But I'll show you that by finding the points. So here we go. Again, the values we use are 0, 1, and negative 1, 2, and negative 2. And once again, we're going to put those in for x. So negative 2 times negative 2 squared plus 5. Negative 2 times negative 1 squared plus 5. Negative 2 times 0 squared plus 5. Negative 2 times 1 squared plus 5. Negative 2 times 2 squared plus 5. And we have to do that arithmetic, right? We have to do that arithmetic. And while I'm taking a picture of a piece of graph paper, why don't you guys just punch out a few of those. So I'll just take a minute to get a piece of graph paper on the iPad. Okay, so there's my piece of graph paper. And hopefully you got around to doing a couple of those. All right, again, remember you do the exponent first. In fact, let me write that out again. Remembering your PEMDAS. We're going to do the exponent first. We're going to do the multiplication second. And we're going to do the addition third. All right, so let's start with an easy one. Let me choose my pointer tool here. Let's choose an arrow. Okay. So we're going to do the exponent first. We'll start with this easy one. So 2 squared means 2 times 2, 4. Next, we do the multiplication. Negative 2 times 4 is negative 8. And then third, we do the addition. So negative 8 plus 5. So negative 8 plus 5 then gets us to negative 3. And we can just keep on going. For the next one above, 1 times 1 is 1. Negative 2 times 1 is negative 2, and negative 2 plus 5 is positive 3. For 0, 0 times 0 is 0, negative 2 times 0 is 0, and 0 plus 5 is 5. For the next one, negative 1 times negative 1 is positive 1, negative 2 times positive 1 is negative 2, and negative 2 plus 5 is 3. And finally, the one at the very top, negative 2 squared means negative 2 times negative 2, so 4, positive 4. Negative 2 times 4 is negative 8, and negative 8 plus 5 is negative 3. And if we go to our picture, I can plot those for you. So left 2 down 3, left 1 up 3, stay in the middle, go up 5, right 1 up 3, and right 2 down 3. And once again, I'm going to be able to connect all of those with a smooth curve, not a straight lines, but a smooth curve, the best I can. All right, and maybe for the last time today, I'm just going to label the points. So negative 2, negative 3, negative 1, positive 3, 0, 5, positive 1, positive 3, and positive 2, negative 3. There's the 5 points. And again, you can see the shape of the parabola. You could also see that the vertex, our starting point, is going to be located at 0, 5, right? And again, just go back to the original equation. Please notice the number on the end, plus 5, tells us that our vertex moved from the center up 1, 2, 3, 4, 5. All right, so any plus or minus number on the end of the equation always moves the vertex, the starting point, up or down in that same direction. So it was a plus 5, so it moves it up 5. And again, the line of symmetry is always through the vertex. So the line of symmetry would go right through 0, 5. And the idea, again, the parabola looks the same on one side as it does on the other. Always a mirror image on one side and the other. Okay? All right, so that's, again, the idea. And I don't want to do too many and bore you because it's just a lot of the same sort of thing. So I want to do one more that's a little more difficult. The arithmetic, we're probably going to be better off using a calculator for. So let's try another one here. Let's try this one. So y is equal to negative 0.75 x squared minus 1. Again, we're going to start off the same way we've started all of them. We're going to start with our xy table, and we're going to put in the same batch of numbers, 0, positive and negative 1, positive and negative 2. All right? Again, we're just going to put those numbers in for x, so we'll put in negative 2. And this time we'll have to use our calculator to punch all of that out. All right, then we'll put in negative 1. We'll put in 0. Don't need a calculator for that one. We'll put in 1. And finally, we'll put in 2. So we put in all of the different numbers, negative 2, negative 1, 0, 1, 2. We put all those numbers into our calculator, and we punch out the y values for each of those. Once again, if you guys have a calculator, why don't you punch a few of those out while I take a photo of a graph paper and get it onto my iPad. All right, that should work just fine. Okay, so there's a piece of graph paper. And now I'll start catching up to you guys. As I showed you earlier, I just want you to be able to put these in. So we'll have negative 0.75 times negative 2 squared minus a 1. And what we get there is negative, there we go. What we get out is negative 4. Okay, the next one, negative 0.75 times negative 1 squared minus 1 will get us out negative 1.75. We shouldn't need a calculator on the next one because 0 squared is 0. Negative 0.75 times 0 is 0. And 0 minus 1 is negative 1. Then negative 0.75 times 1 squared minus 1 is negative 1.75. And finally, negative 0.75 times 2 squared minus 1 is negative 4. Okay, so again, we have 5 points. We used our calculator to come up with those. And the points then left 2, down 4. Let's see, left 1, down 1.75. So left 1 and down 1.75 would be right about there. Stay in the middle, go down 1. Go right 1, down 1.75, so right about there. And right 2, down 4 would put us right about there. Again, do a connect the dot puzzle. And then once again, kind of use your imagination that the curve would keep going down in that direction and keep going down in that direction. All right, so the vertex, as you can tell from our equation, the vertex has been moved down 1 from the origin. So this point right here is the vertex. It's the starting point for our parabola. And so if you wanted that as an ordered pair, I think some of your assignment problems ask for that. So that would be located at 0, negative 1. And the line of symmetry always has to go through the vertex. So this is then going to be a line that goes through the x-axis at 0, right? And it would look just ballpark something like that. It has to go through the vertex, so it looks something like that. Okay, again, the idea, mirror image on one side and the other. Always looks the same on either side. Okay, so that's a pretty decent start for section 2. I'll be back tomorrow where we're going to do some more problems involving this plus or minus number on the end. We'll do a couple extra little things tomorrow as well. Okay, so feel free, dig out your assignment and go ahead and get started on the assignment. You should be able to get started pretty well, and then we'll finish everything up tomorrow, and then this one will be due then on Friday. Okay, all right, so we'll see you tomorrow. I hope you're having a good day.